Welcome to another tutorial of Profilan YouTube channel. In this particular video, we're going to have a discussion on some of the important mathematics concept that you need for you to be able to excel in A-level physics. So we are going to draw a right angle triangle like that. We shall have, this is going to be the vertical component, and then here we shall have a horizontal component. So meaning that if we want to find the vertical component of this force of 5 Newton, let us draw a right angle there. So we shall have a triangle at that given point whose hypotenuse is 5 newtons. But we need to know what is the vertical component of force F. So let's say this is our force F. Then the vertical component, let's call it V, meaning the vertical component of F, and the horizontal component we're going to be FH, meaning the horizontal component of this force F. So we are going to use the concept of trigonometry, and that is SOHCAHTOA. So this is the important mathematical concept that you need to know for A-level math. So that if we are given this as the hypotenuse, and then it means that we can be able to get the opposite. This is actually opposite, and this is adjacent. So the adjacent is where we have the horizontal component, and the opposite is where we have F vertical, the vertical component of this force. So if this force of 5 Newton is applied at this point, the question is, in the y direction, what quantity or what magnitude of the force is acting in the y direction, and what magnitude is acting in the horizontal direction, because this force is acting at an angle in that direction. So we're trying to find in the vertical direction, what is the magnitude of this force? Yeah, if this object is going to move upward, what is the value of the force that is going to be moving in the vertical direction and also in the horizontal direction? So for us to get the vertical component, you can see now we are having the opposite and the force, right? So we are going to see the force in the hypotenuse. We're going to say this is a sine of the angle theta is equals to opposite of a hypotenuse. So this is the kind of math that you are going to use here. So meaning you can say this is sine 15 is equivalent to opposite is the force in the vertical direction, but hypotenuse is the 5 newtons that we are having at that point. So which implies that the mathematical concept, of course, of rearranging this, we can be able to say this can be rearranged to vertical direction. So the force in the vertical direction is 5 sine 15. So we can be able to work it out. Let's see if we work it out. What are we going to get at that given point? Right, so this is going to be 5 sine 15, and ensure that your calculator is in degrees. Remember, I've always kept on saying that you have to ensure that the calculator is the correct unit. So if we put this here, I'm getting my answer is equivalent to 1.29 Newton. So the force of 5 Newton, so the vertical component of this force is going to be 5 sine 15, which is equivalent to 1.29 newtons. So moving to the second part, for part B, this is actually for part A. For part B, you are going to resolve this force in which components? In the horizontal component. So we have adjacent and hypotenuse. So we are going to use cosine. So we are going to say cos theta is equals to adjacent cos theta equals to adjacent of hypotenuse. So remember that theta is 15. Yes, now we can be able to substitute our theta is 15. So we're going to say cos 15 is equals to adjacent. Now our adjacent is the force F in the horizontal direction. So we can say F subscript H over 5, which is the hypotenuse. So which means that this can be rearranged, and we are going to have our FH is equals to 5, 5 equivalent to 5 cos 15. Now, if we substitute this, if we try to substitute this, let's check what we are going to get. We have to put now into our calculator so that we can be able to see 5 cosine 15. It's actually giving us 4.83 as our answer here, 4.83. So you need to know how to resolve vectors. Resolve vectors. Now we can be able to look at another scenario. Now, because if we are given this at this particular angle, let's see now if you are given a different, supposed to now resolve this vector so that we can be able to state, for instance, part A, you are supposed to state the vertical component and the horizontal component of the force F that we're given here. And the force F is 15 newtons at an angle of 30 degrees to the vertical. Remember the previous example that we had done was 15 degrees to the horizontal, but now this one is 30 degrees to the vertical. So which will mean that at this given point, we are going to draw now our triangle at this level here. We shall have our triangle. You can decide do it like that, or you can even decide find the missing angle here, and then you'll be able to approach this. But for simplicity, I'll decide, and I'm going to give you the two both scenarios. So we are going to identify and say that, okay, our angle is going to be 30 degrees, and then the horizontal component is this one, which is actually, which will have been also at this given point here, right? So we can say this is the force in the horizontal direction is this component, and the vertical component is the force F in the vertical direction, this part that we are having here. So remember, this vertical component is actually adjacent to this angle, and this vertical component is adjacent. Tuende kunywa dawa kwenda pale. Viazi za nini? So the vertical component that we are having here is actually this vertical component we are having at this point is actually adjacent to this angle. Always try to ask yourself, is the component that you are working out adjacent, or is it opposite to that angle that you are being finding? So in this case, of course, we are going to use SOHCAHTOA also. So which means that we are going to say now, in order to work out the vertical component, we have adjacent and we have hypotenuse. Remember, this is the longest side of that triangle. So we are going to say cos theta is equals to adjacent of hypotenuse. That will enable us work out the vertical component in this case. Then we will be able to see here F in the vertical direction. So we can say cos the angle is 30 is equals to adjacent, and our adjacent is F in the vertical direction, and our hypotenuse is 15. So which implies that to work out this, we're going to have F, the force F in the vertical direction, or the vertical component, is going to be 15 cos 30. So let us try and put it in a calculator and get to see what we can be able to get here. This is 15 cos 30. That translates to 12.99 Newton. So this force, when it's pulling at 15 newtons at an angle of 30 degrees from the vertical component is 12.99 Newton. Now, for us to find the force in the horizontal direction, actually at that point we're going to say that this is going to be our opposite and we have the hypotenuse. So we are going to say cos sine 30 is equals to opposite, but our opposite is F in the horizontal direction over 15, which implies that F in the horizontal direction is going to be 15 sine 30, and that becomes what? That becomes 15 sine 30 becomes 7.5. The answer is 7.5 at that point. So you're going to say here, our answer is 7.5 Newton. 7.5. In part B, there is an object moving 7 meters at an angle of 10 degrees from the horizontal. So we are given this as the velocity v. And now we are supposed to find what's the speed at which this object is moving in the vertical direction. Which speed is it moving in the vertical direction, and at what speed is it moving in the horizontal direction? So we're going to say this v in the y direction, and this is the velocity in the x direction. Sometimes you find that it's given in this format, v in the y direction or v in the x direction. Just the same thing that we're talking about. Horizontal and vertical is the same. So if we are finding the speed in the vertical direction, remember, if this is v in the vertical direction, is the same thing we shall have here. That is v in the vertical direction, or vy. So at what speed is this object moving in the y-axis, in the y direction? That is what we're trying to find. So this is 90 degrees at that point. So meaning that we can be able to use opposite. Remember, this one is opposite, and this that we're given 7 centimeters is the hypotenuse. So we can be able to say sine 10 is equals to opposite, which is vy, over hypotenuse, which is 7. So therefore vy is going to be 7 sine 10. So if we work out this, working out this, I'm getting 1.22 meters. And the other part that we are having here now, to get in the x direction here, in the x direction, we are going to have this side here that we are finding is adjacent to the angle that we are being told. So which means that we are going to use adjacent and hypotenuse, and that is actually cos theta equals to adjacent over hypotenuse. That will mean that this is going to be cos over 10 is equivalent to adjacent, but adjacent is velocity in the x direction over the velocity that we are given, which is 7. So v in the x direction is going to translate to what? If we rearrange this, we are going to have 7 cos 10 degrees. 7 cos 10 degrees, which will mean substituting 7 cos 10, this becomes 6.89. 6.89. So we shall say this is a 6.89 meter per second. Meter per second. Of course, this is also meter per second because we were talking of velocity. Now, Now that is about resolving vectors. So I believe at least you are following what you're supposed to do. Now we have an object here. This object is projected in the horizontal direction now, and it's moving at a speed of 46 meters per second. In A level, we shall be giving this unit as a meter per second, like that. Get used to that. That's how the meter per second is usually given. Subscript -1. Get used to that one. Yeah. So, of course, here we have 90 degrees. So, what's the velocity in this direction? What is V here? Because this V that we have is V in the horizontal direction. V in the horizontal direction. So what is this V? Suppose you are asked a question like that. Yeah. And if you are asked to work out V in the vertical direction, V in the vertical direction, what will you do in order to work it out? Now try to work it out and then write in the comments, and so that I can be able to see what you got, and then you check with us what we are getting now. So we are going to say, since we are having this object moving at 46 meters per second in the horizontal direction, but the angle now, you are at the velocity at which this was, remember it was projected at 47 degrees from the horizontal. So we can be able to say that this is hypotenuse and this is adjacent. So we can say cos 47 degrees is equals to adjacent, which is VH over the hypotenuse. But in this case, we have our V, which is VH, which is 46, over hypotenuse, which is V. Then we can be able to rearrange this. So the kind of mathematics you need to know. You need to know how to rearrange formulas and then making the subject of the formula and finding. So if we make this the V the subject of the formula, it will be V is equals to 46 over cos 47. Yeah. Cos 47. So we need to put it in the calculator. Cos 47. This becomes 67.45. 67.45 meter per second. So the velocity in this direction was this value that we have gotten at this given point. Now, what was the velocity in the vertical direction, like that? The velocity in the vertical direction is going to be, this is opposite, and this was adjacent. So now you need to avoid, because this one we have found V, so maybe if it's wrong and you use it to find this one, you may be penalized. So it's better if you are not sure whether that was correct in exam, use the one that was provided and the one that you are finding. So we can see we have adjacent and we have opposite. So that is tan. We can be able to say tan 47 is equals to what? Tan 47 is equals to opposite over adjacent, but our opposite is V in the vertical direction. This is V subscript V of 46. So V in the vertical direction, let me just write it initial like that. You can be able to see vertical means in the vertical direction. That's going to be 46 tan what? 47. I believe that's clear. Yeah, let me just move this. I think it's taking a lot of space. V in the vertical direction is going to be 46 tan 47. 46 tan 47. So let us try to work it out and see what we're getting. This becomes 49.33. 49.33, and that is meters per second. Meter per second as our velocity in the vertical direction. So once we have done this, I need now to show you where are we going to use this? Why are we doing all these resolving vectors? So that at least you have an idea uh, how questions are going to be asked, right? We have done resolving vectors. Now I'll give you an example whereby where you are going to apply this knowledge. This knowledge can be applied when you are working out projectiles. An object is projected from a point, and then you are asked to work out what's the distance of this object. How did this object move? So that is application of resolving vectors. So we can say application So application of resolving vectors into in projectiles. So when we are talking of a projectile, for instance, if an object is projected such that it's projected an object is projected an angle at an angle like that, you realize that this object is going to move like that, and then it will land somewhere here. Yeah, the object will move at an angle, it reaches the maximum height, and then finally it's going to land somewhere there. So you'll be given questions with projectiles. Maybe you are told an object or a stone was projected at an angle of 30 degrees to the horizontal, and if this was moving at 35 meters per second, then you are asked to state what is the maximum height reached by this projectile. Yeah, what is the maximum height reached? And also you may be told to work out what is the range, range, meaning the distance s, which is the range, the distance from the point of projection to where this object landed. Those are some of the questions you'll be asked. You may be asked, how long did it take to reach the maximum height? Now, something that you need to remember is that for you to work out the maximum height, for instance, we can say maximum height. Um, so the most important thing to remember here is that when an object is projected at an angle, it's going to have a vertical component and horizontal component. So you are having a vertical component at this point, at the same time, there is a horizontal component at this point. So which will mean that we can be able to ask ourselves in the vertical direction, what's the speed of this object? In the horizontal direction, what's the speed of this object, right? Now, the vertical component of this projectile is going to be affected by gravity, right? So we need to resolve this vector that we are given here into vertical and horizontal components. So if this is our v, which is 35 meter per second, we need to know v in the x direction is what? We also need to know v in the y direction is what? Now, this v in the x direction is going to enable us work out the distance covered in the horizontal direction. And this v in the y direction is going to enable us work out at what height is this object is going to move to the to reach the maximum height. So how high this object is going to move. That is going to be determined by v in the y direction, but horizontally is v in the x direction. Now, this brings us to a point whereby we can be able now to resolve this. And to resolve this, we have said, first things first, we are going to use Sokatoa. So if we are finding this vertical component v in the y direction, we can be able to extract a triangle and say we are resolving this. Yes, this is in the y direction, this is in the horizontal direction. Then, which will mean here that we can transfer this and then we put it here so that we have our height at this given point. This is v in the y direction, and this one here is going to be our v in the x direction. So the angle that we were given in this case is 30 degrees. Now, applying SOHCAHTOA, we can be able to say to find v in the y direction, we are going to use sine, but of course, this is 35 meter per second, which is v. So we are going to say this is our hypotenuse. So we can say sine 30 is equals to opposite, which is v in the y direction, over hypotenuse, which is 35. So v in the y direction is going to be what? Is going to be 35. This is multiply both sides, sine 30. So if we can work out the velocity in the x direction, in the y direction, velocity which is going to be 35 sine 30. This translates to 17.5 meter per second. So this is 17.5 meter per second. meter per second. So in the vertical direction, this object that was projected was moving upward at a rate of 17 meter per second. But in the x direction, at which speed will it be moving in the horizontal direction? So that is the one that we are finding here. So we can now say at this point that because this is adjacent and hypotenuse, so we can be able to use cos 30 is equals to v in the x direction over 35, right? So meaning that we can now say this is going to be v in the x direction is going to be 35 cos 30. Let us try to work it out. 35 cos 30, which translates to 30.31 meter per second. 30.31 meter per second. Meter per second. So this object was moving in the x direction at 31 meters per second. So when an object is projected at an angle like that, it means it's moving, yes, upward, at the same time it's moving in the horizontal direction. So which will mean that we are going to have two sorts of motion. But the horizontal motion is always constant and is not affected by gravity. But motion in the vertical direction is going to be affected by gravity. So this object will move up as it's slowing down until it reaches the maximum point. Again, it starts coming down. So any point you are told to work out the maximum height in your A-level physics, you are going now to use the vertical component. And the vertical component, we have gotten it here. So we can be able to say initial velocity. For us to find this one, we need the initial velocity with which the object was projected. So this is going to be initial velocity. And our initial velocity in this case is going to be this value that we are having here, which is going to be 17.5 meter per second. Then at the highest point, the final velocity is going to be, final vertical velocity is going to be 0 meter per second. Because if you project an object to move up, the speed of the object will keep on slowing down until it reaches the maximum point. It will be kind of momentarily at rest here, right? The speed at which this object is moving up at this point will be 0. So that's why I'm saying the object will be moving upward at 17.5, but it will slow down until it reaches 0 meter per second at the maximum point. But the gravity or acceleration of this object is gravity, which is going to be actually negative 9.81 because the object is moving upward, so it's moving against gravity. So that's why we are saying now it's actually negative value. So for you to work out the maximum height reached, we have the equations of motion, the Suvart equation of motion. The first one is V equals to U plus AT, V squared equals to U squared plus 2AS. Also, these are the very important formulas that you need to remember for AS physics. And then we have S equals to UT plus a half AT squared. And then we have the last one, S equals to U plus V over 2 times time. But if you look at this equation that we're having at this given point, you need to remember that for you to use a particular equation, you must ensure that you have enough information or sufficient information that's going to enable you work out that. So if you look at that, which would be the most appropriate formula we can be able to use in order to work out this question, the most appropriate formula is the one that is having U, that is having V, that is having A, and also that is having S, which is displacement, the one that we are finding. And our S is actually H maximum, the maximum height that we are trying to work out for this question. So in that way, the most appropriate formula to use in this case is V squared equals to U squared plus 2AS. Now, at this given point, we can now say our final velocity is 0 squared equals to initial, which is 17.5 squared, plus 2 times A. Our A is negative 9.81 times S, which we are finding. And in our case, S is the maximum height reached. So meaning that we can now simplify this. Let us try to simplify this. So if I rearrange this, I'm going to have 0 is equals to 17.5 squared minus 19.62 S. So I can take this on the other side, and then I will have S is equals to 17.5 squared over 19.62. So we can be able to work out that and see what is this going to give us, because if we put 17, 17.5 squared divided by 19.62, this becomes 15.61, 15 meters. 15.61 meters. So this object moved upward a height of 15.61 meters. What else can you be asked in this question, right? What else can we be asked here? So another question that you can be asked at this given point, let me just try to use this page that I'm having here. For part B, another question that you can be asked Another question that you can be asked in this question are time to reach the maximum height. How long does it take the object to reach the maximum height? So in that case, we know the initial vertical velocity. The initial velocity in the vertical direction is this. The final velocity in the vertical direction is this. The acceleration in the vertical direction is this. Now, for you to find time to reach the maximum height, you are going to use the first equation here. We can be able to say this is 0 equals to 17.5 minus 9.81 t. Then we can be able to rearrange this and say t is going to be 17.5 over 9.81 because I've already taken this on the other side and then divided by 9.81 both sides. So we are having our equation like 17.5 divided by 9.81. So let us try to work it out and see. Divided by 9.81. So that becomes 17, rather, it gives us 1.78. The time it takes this object to move to the maximum height is equals to 1.78 seconds. So if you are asked also to find time of light is time taken to go back to the time taken, the time it takes for this to fly up to this point. That is what we call time of flight. So time of flight, the time this object was in air, that's what it means, right? So we are going to, because it takes time 1.78 seconds to reach the maximum height, the one that we have gotten here. So also it will take 1.78 seconds to come to this point. So therefore, we are going to say time of flight is going to be equals to 1.78 times 2, which is going to be, this is 6, yes, 5 carry 1, then it becomes 3.56 seconds. 3.56 seconds. Another question that can be asked here, what's the range? The range is this distance that we are having here. What's the range? How far did this object land on the other side? So remember, this object was moving vertically upward at a speed of 17.5 meter per second. But in the horizontal direction, in the x direction, we had found what was the horizontal component. And the horizontal component speed, we got it to be 30.31 meter per second. So which means this is now the one that we're going to use. This is the range. So the range here is going to be equals to u in the x direction times time of flight. So, and our time of flight is that. So this is going to be 30.31 times 3.56. Working out, that becomes 107.9 meters. 107.9 meters. So this distance from where the object was projected to where it landed is actually 107.9 meters. So those are some of the mathematical concepts that you really need when it will come to A-level physics. Resolving vectors. resolving and vectors. Then you are asked, what's the work done? All right. What is the work done in this case? Now, you cannot be able to say, we know that actually work done equals to force times distance. Work done equals to force times distance. So, but our force is not acting in the direction of motion. The force is actually acting at an angle here. The force is acting at an angle. So, which means we are going to resolve this force into the horizontal and the vertical component. So we need to know what is F in the X direction. What is F in the X direction? Because the horizontal distance is 10 meters. So we have to resolve this so that we know what is the horizontal component of the force that was acting at 18 degrees. So in order to work out that, remember we have, this is our adjacent, and this is hypotenuse. Of course, remember this is 90 degrees here. So we are going to say adjacent and hypotenuse, that is actually cos, right? Cos theta is equals to adjacent over hypotenuse. So which will mean that our adjacent is just actually fx. So which is cos 18 is equals to adjacent, which is f in the x direction, of hypotenuse, which is 25. So that will mean that the force in the x direction is going to be 25 cos 18. If we work out this, we are going to realize that this is going to give us what? This is 25 cos 18, which is going to translate to 23.78. 23.78 Newton. So the horizontal component of this force is 23.78. So which means that work done is going to be equals to F cos theta times the distance. F cos theta times the distance. But F cos theta is this value that we have gotten at this given point. So this is going to be 23.78 times 10, which is going to be 237.8 joules. That is the work done using resolving of vectors. So you are going to realize in AS physics, this concept of resolving vectors is going to be appearing in many of the concepts that you are going to do. So it is high time, as you are preparing for your A levels, to ensure that you are refining on this particular area. So another area that you are going to see also motion in inclined plane. Another area that you are going to see resolving vectors is also motion in inclined plane. So for instance, you have a box. We have a box that is resting on an inclined plane, and this angle of inclination for this case is 14 degrees. Now you'll be asked different forces that are acting here. So remember, this box has some weight. So the weight of this box will be acting vertically downward like that. So the first force that we have is the force that is acting vertically down like that. And actually this is the weight of the box. And this weight of the box, remember, weight is given by, remember, weight is mg, right? Will be acting vertically downward like that. Another force involved in the motion of or involved in inclined plane is the force that is perpendicular. Also, let me just put all these forces acting from that point. The force that is perpendicular to the plane, that is the normal force, and the normal force is perpendicular to the inclined plane, like that. This is our normal reaction force will act that. So if there is a normal reaction force, remember this box is going to be exerting a force into the inclined plane. So there is a force acting in that direction, right? But what we need to remember at that point is that the normal and this force that is acting in this direction, they are equal. So this is the force that is there. The box is exerting on the inclined plane, and the inclined plane is going to exert an equal and opposite force on the box, right? Now, we can be able to, yes, resolve vectors here. And I want you to be very, very keen at this given point. So there is this force, yeah, there is a force acting parallel to the inclined plane. So that force, we can be able to put it here. But number one, I want you to remember that if this was a force that is vertical, acting vertically down like that, then it means this is 90. Then we can be able to know what this angle is. Because if this is 90 and this is 14, we can be able to say the remaining angle here will be 90 minus 14, which is going to be 6, and that is going to be 76. So this is 76. Therefore, it means also this angle is 14 degrees at this given point. This angle here is also 14 at this point. So if this angle is 14, this angle we have at this point is also going to be 14. The reason as to why that is the case, because if we have gotten that this is 76, then the all of this angle is 90 here. The all of this angle here is 90. It means this section that is remaining on the other end is going to be 14. So if this is 14, also we have similar triangle. This is also 90 at this given point. So meaning that if we want to find this component, is going to be mg sine theta, and this component here is mg cos theta, right? Because of this triangle we are having at this given point. So anytime you are going to be working out motion on inclined plane, something that you need to remember, if we are talking of motion on inclined plane, the first thing that you need to ask yourself, which angle is here? If this angle is theta, and then we have an object that is resting at this point here, if we have an object that is resting at that point there, so it means that there is a force. There is a force that object is exerting on the inclined plane. It will be that force there. And there is a force the inclined plane is exerting back to the object is the normal force at that point, normal force. And there is a so there is also a vertical force that is acting downward like that. So this force that is acting down is mg, right? The force that is the object is exerting on the inclined plane is going to be mg sine mg cos theta, because if this angle is theta, then also this angle is going to be what? Theta. Okay. The force that is pulling this object down the inclined plane is equal to the force that is this component. This force, this component is equal to this component because they are parallel and acting in the same direction. So this one is we've said is mg sine theta. So this one is also mg sine theta. Okay, so you can even master it in that way, that the component that is acting down the inclined plane or parallel to the inclined plane is mg sine theta. Into the inclined plane is mg cos theta, right? And this angle that we are having here is the angle that we have at this given point. Okay, so that, what does that really tell us? If we have an object on the inclined plane whereby this angle is 14 degrees, right? 14 degrees. Let me use the marker that is quite visible. This is the inclined plane, and this is 14 degrees. And then we have an object. We have an object of mass 10 kilograms. We have an object of mass 10 kilograms. So you are asked, what is the force this object is exerting on the inclined plane? It will be this force that we are having at this point, right? The force this object is exerting on the inclined plane, which is going to be mg cos theta. And our mg cos theta in that case is going to be 10 times 9.81 cos our theta is 14, is also 14 here. So if we work it out, we are going to see the force it's exerting to the inclined plane is going to be 10 9.81 cos 14. That translates to 95.19, 95.19, 95.19 Newton. So this object of 10 kg exerts a force of 95.1 Newton, 19 Newton into the inclined plane. So if you are asked the force that is pulling this object parallel to the inclined plane, the force that pulls this object down the inclined plane is going to be mg sine theta. So this is going to be this mg sine theta. So that's going to be 10 times 9.81 sine 14. Sine 14. So if you work out this force, we're going to get this force is going to be 10 times 9.81 sine 14. Working out, it becomes 23.7, 23.73, 23.73 Newton. So the force that is pulling it down is 23.73. So you really need to have a good understanding on resolving vectors so that anytime you are going to be given questions for physics, you are able to proceed. See you in the next video.